Welcome back everyone. I'm just making a quick video here to help us with work out of the textbook, and I think we're working on perimeter. And what I've got here is again the ruler that I use as a straight edge. All the shapes that you're dealing with today are shapes formed with a straight edge. There's no curved lines, so that simplifies things a little bit. And what we want to do is something kind of like this. We just want to write in a little, draw a little sketch like this. It's pretty rough, but it helps us transfer the information out here. And what we're looking for, I call them ticks. And what I'm looking for is that these ticks indicate that these two lines here are the same length. And what we're dealing with perimeter, we're adding up the outside lengths of all this shape here that forms a rectangle. So bear that in mind, and just think about our units here too. Because they are lengths, we're dealing with millimeters, centimeters, meters and kilometers. Be very wary if you need to, if they're not all the same units, you might have to do some conversions before you add things up. So they're the kind of little, what do I call them, traps that are set for you to make sure that you're not asleep and that your brain is working and you're being aware of these things. So I'm going to jump behind the light board and show you a few other little tips and tricks that I've got for you. So we're behind the light board here and we're looking at the measurement topic. We're looking at perimeter, and the first thing that I want to say to you, instead of writing out perimeter all the time, just use a capital P. All right, it's a little bit of algebra, but everyone understands that capital P stands for perimeter. And what is perimeter? It's just a distance around the outside of a 2D shape, and I've got a triangle drawn here for you. But what I want you to notice is that I'll draw it again. If I put two, I call them ticks, they're like little marks on the line that says, hey, these marks, if they're the same marks, those lengths are the same, because nothing's drawn to scale. And it's an interesting thing to observe students who grab their ruler and start measuring a length that they don't know. So what's it telling us is that if this is 5 centimeters, this side is also 5 centimeters over here. And finally, to do our working, we would write P for perimeter is equal to the sum of all these lengths. So it's as simple as adding them all up like this. And my suggestion to you here, even though this is a really simple example, is that it's hard to see, but I would imagine putting my finger on each of those measurements as I write them down to make sure that I've got them all. Because it's a pretty common mistake just to miss one of the lengths and then suddenly your answer is wrong. So that's a really simple example. So let's get a sense of some more challenging problems. Okay, so I'm just going to draw a couple of shapes here, label a few things and leave a few things out. I'm going to call that 3 meters and 6 meters. There's a side here that I've got no idea what the length is because they didn't tell me and they want me to work it out. And same deal down here. So I'm just going to change the color of my pen and show you a few ways here where you can actually work these things out. So if this is 2 meters and this one's 6 meters, and sometimes they don't show you, they're all at right angles in here, okay? So keep that in mind. This length in here has to be 4 meters, okay? Because 2 plus 4 is the same as 6. And for a similar sort of reason, I imagine bringing that line down and that line down. So this one has to be equal to 8 meters. So now I'm in a position I can work out what the perimeter is. I know all the lengths. And what I'd be really, what I'm trying to stress or reinforce here is that you go around in a real systematic kind of way and write all the numbers down, because if you miss one, you get the answer wrong. So what am I seeing here? That's 10. Those two are 10, so I'm at 20, and then I'm at 28. So the perimeter here is 28. What were my units? They're in meters, and there's my final answer. I've added all those things up. So next, let's do another one. Similar sort of shape, I guess. I'll just pick a bit of the board that I can use here, and I'm going to draw this. And in this example here, all the corners are at right angles here. And not only that, they've given us some information that these all sides are all 4 meters. And I'm given one more piece of information here. I've got to work out all the rest. So, not a lot to go on, but I need to change the color of my pen just to show you how I'm thinking about it. And what I'm doing is I'm seeing these ticks here, they're all the same, and my drawing's not to scale, and they're all different sizes, but I do know that's 4 meters, and I do know that's 4 meters as well. So I'm thinking this length, moving it up here, I'm thinking about moving that there, and suddenly add those together, I'm at 10 meters. And then finally, if I move these sides over here, well, I can see that's 8 meters. And now I can go and work out the perimeter of my shape. And what I'm going to do here is something slightly different. I've got 3 of these guys, so 3 times 4 plus the 6 plus, I'm going to call that 18 because I added these two together in my head as I went along. So here I'm at 12, and if I add these two together, I'm at 30. So my final answer here for the perimeter has to be 36 meters. Okay, don't forget the units. Now, here's a bit of a Jedi mind trick. I'm going to redraw this shape. And I knew they were 4, and I knew that was the same, and I knew that, and this was 6. Watch what I do here. I might have to rub a little bit of this out, but I'm shifting that 6 meters down here, and I'm shifting the 4 across here. And it has made my calculation a little bit easier, because that's 10 they're added together, and this is 8. And what I can see now, because it's like a rectangle, I might have to use a space in here, but what have I got? I've got P equals 2 times 8 plus 2 times 10, and that's 16 plus 20 is 36 meters. So I've just demonstrated 2 different ways to think about what's going on there to arrive at the same answer. So what I've got for you, I'm just kind of running out of board here, so I'm just going to extend that last idea of changing the shape and making life easy for yourself, because I've got an interesting problem here where I've got a shape that's really funny and it doesn't have too much on it. And here's my, whoops, going the wrong way. Here's my shape. I'm doing a really rough job of this. And all I know, this might be 15 millimeters, this side here, and this side is different. And this is 20 millimeters. Now, there's a lot of information that we don't know in that sort of reverse staircase type thing. But if I apply the same sort of thinking it doesn't really matter if I drag all these bits of the shape, all the horizontal bits, drag them down here and fill this line in here. All those bits will add up to 20 millimeters. And what I can also do is drag all these vertical parts over to form the other edge. And that will be the same as this guy. We're at 15 millimeters here. And now I've got to work out the perimeter of this shape, and I might do it in the space up here. That what we've got P is equal to 2 lots of 15, which is 30, plus 2 lots of 20, so 40. And so the perimeter of this shape is 70 millimeters, if I remember to include the units there. So what I'm kind of trying to get you to do in this final part of this video is just be a little bit more flexible with your thinking. And it's always easy to add up the outside of a rectangle because there's only 4 sides to deal with. And more than that, those 4 sides, 2 of them will be the same length and the other 2 will be the same length. So at the end of the day, if you can shift your thinking away from, and the opportunity exists to move away from this really structured way of thinking into moving into this type of working, then take the time to do it. All right, thank you.